Okay, everybody, welcome along to week 4, talk 2 in the Higher Diploma in Computer Science Programming Fundamentals. Just checking in with you, making sure everything's okay. Yeah, we've got a couple of you who are replying to the thread. If you are watching, we would appreciate it if you could go to Slack, just respond to the message I just posted, so we know who we're dealing with. Okay. That's great. So quite a few different things to have a look at today. So let's get started. In our last talk, we finished by getting into classes and objects, and we introduced properties, methods, and the dot operator. The slides and the theory actually take longer than to just actually do what we want to do. So it kind of, if anything, probably complicates things, but we'll be going back over what we did the last day, recapping again, and you'll see that that's a common theme in most of the talks. We need to go back over what we covered in the last class in order to progress. Okay, so once we do that, we'll then take a look at creating your first class, which brings us into this notion of object-oriented programming. We're going to be creating a class called Spot, which draws a circle on the screen, and we'll be using that example to explore things like constructors, and we'll have default, passing in parameters, and a phrase we've already come across, overloading. We also will move on to, oh, I think I've skipped a slide here. Yeah, sorry, that's what we call, we stopped at dot operator. I should have looked at creating your first class and constructors, and that's what we'll be doing today. Before we get on to that, though, I just want to point out we've got an extra video that I posted after the last class, just in case. Let's take a look at where that is. So if we take a look at our website and tutors, so week 4, scroll down. Week 4 is this week, and the video that I made was actually to cover some slides that we'd skipped over the last day and the previous day. So I put that extra video in week 3. So let's just step back, go down to week 3 methods. And if we scroll down here, you'd see that I had started the slides on strings, but I didn't complete them. So what I've actually done is I've gone back and republished this site, split the notes into 2 cards, and as you'll see here, strings extra is where the extra video is, and you can watch it by pressing play video. Okay, and as I mentioned the last day, the materials that are in there were actually covered anyway again in the next class, so we have overlap between each of the talks. Okay. Okay, let's get rid of that. So we're pointing out the extra video. That's the first thing. And we have an assignment rubric. So I'm getting quite a few questions about the assignment, which is normal. We'd like you to keep posting any questions you have on the Slack channel, and let's start getting all of our class involved in answering each other's questions. You don't have to wait for the lecturer or the lab assistants. Speaking of lab assistants, I forgot to introduce Jonathan and also Patrick. Jonathan has said that he will be available at 9 o'clock tonight, Wednesday, and again at 8:30 on Friday, where he will respond to any questions live. So if you're looking for an immediate answer, you will definitely get it tonight at 9 and on Friday night at 8:30. So if you've got questions on the labs, if you've got questions on the assignments, we can turn that into quite an active session, hopefully on Slack. Okay, so just make a note of those times. Okay, so let's take a look at the rubric. I've actually posted the rubric into Slack, and you can take a look at that in Slack if you want to download it. We'll take a look at it here. So here's the assignment. So the idea of a rubric is really a marking scheme, and traditionally you would have been asked to do something as an assignment, but usually never given any help in relation to how the thing was going to be marked. So you could get very disappointed because you spend a lot of time working on a certain aspect of an assignment which really had no value to it in relation to marking. I'm very well aware of how time poor everybody is, so we're trying to remedy that by giving you out the marking scheme, or rubric as we call it, in advance. So before you even start your assignment, you now have a rubric. The grades that we use in college are excellent, very good, good, pass and fail. And you can see the percentages associated with them. Eventually everything has to come down to a number. So how do we get to those numbers? Well, we use these as categories or grades, if you like. And for everything that we're looking for, we would effectively evaluate what we're doing and come up with a grade. And then you can turn the grade into a mark within that category. So for example, part of your assignment rubric asked you to get for a mark out of 5, so 5% of your assignment was related to comments, indentation, naming, structure of your code, inclusion of a README and a reflection. So what I've done is I've filled out this rubric for you to show you how you might mark yourself and to give you advice on how to mark yourself. So in relation to this category, part A, I've given details about each one of these things that we're looking for and what it might mean for that category. So let's start with the worst one. So for example, you won't get any marks at all. You get a fail mark if you had no comments, there's no indentation, it doesn't use correct use of naming of methods and variables. If you don't have a README included and you don't have a reflection included, then you would get a fail. So what you would record for that would be a mark in the fail category, so less than 40%. Now, you might have had 1 or 2 of these things, so that would give you a mark, 10 or 20%. But if you had none of them at all, then you would be recording as 0. Okay? So that's how you come up with the mark. If we take a look at the pass, barely meets what was asked, a comment used in the code somewhere, indentation, code used correct indentation once, correct use of a naming method and variable once, README included, the reflection included, but maybe no line numbers, then that might be a pass. A good mark then would be an improvement on that. So for example, you might have used one of either a single or a multi-line comment. You might have used some methods. Indentation, code uses correct indentation sometimes, but not all the time. Correct use of naming methods and variables sometimes. Had a README included, had a reflection included. Okay, but only partially included line numbers. So you get a good mark for that. Very good. Comments, mixture of single and multi-line comments. Most methods described. Indentation, the code uses correct indentation mostly. You see this word mostly popping up a lot, so it had the correct naming methods mostly. The README was included, and the reflection included and completed mostly, including line numbers. Excellent, you did everything really well. So comments used both a mixture of single and multi-line. Each file and method was described. The indentation was done correctly. Naming, so you had meaningful names used. That should say camel case, not camcel. So camel case, action words for methods, correct use of naming of methods and variables throughout. You had a README and you had a reflection. It was completed fully with all the line numbers. So you can see that the typing up how you might answer it actually is going to be a lot harder than actually you filling it in. So what you do is you pick out which one of those categories, excellent, very good, good, pass or fail, best reflects your solution. And then based on that, that gives you a category that we showed you here. So you know which category and which percentage category you're in. So you're either less than 40, you're greater than 70, or you're in one of the 10% bands between 40, 50 and 60. Okay, so now you have a good starting point. So let's say for that category, I've done my assignment and now I'm going to submit. So for part A, which grade above describes your work? Give yourself a percentage. And having reviewed my work according to the detailed rubric above in relation to naming, commenting, indentation and submitting, my work falls in the very good category. And it's somewhere in there, and based on all of those things considered, I say I'm worth 65%. So to record a mark, X out of 5 for this first part of the rubric, I'm saying 65% of 5 is 3.25, and to the nearest whole number, that's 3. So you're either rounding up, you're rounding down, you give yourself a mark. Okay, so I would have got 3 for that. Part B, set up and draw, where you're asked to include those. So if you included both of them, and you show the line numbers where they're included, that's an excellent mark. You're using both of them. Good might be both were included, but maybe one of them is empty. But you also included the line numbers. Pass mark might be both were included, but empty. So you had an empty setup, an empty draw. Yes, you'll get marks for that because that's what you're asked for. So yes, it passes, but only barely. And a fail is you didn't include those, or you included them, but they don't work. So setup and draw are fully working for me, so I score myself an excellent 100% and give myself 10 out of 10. Okay. Part C is an if statement. So your assignment needs to include an if statement. So it's excellent if you have multiple if statements with branches. Better again if it has nested ifs. So that's an if statement inside an if statement. Of course, you have to say where you found all of these, so you'd include the line numbers. You get a very good mark, possibly if you had multiple if statements, but you didn't have any nested ones. A good mark, a number of simple single branch if statements included, but empty. A pass, a single if statement included, and the line numbers are shown. A fail is you didn't include any if statements. So for that section of the assignment, you need to look at your code, identify where you have the if statements and what type ones you have, and then score yourself excellent, very good, good, pass or fail. And as an example, this is, I have multiple if statements with multiple branches. I didn't use a nested if, but I have many branches and I used if statements inside the loops. So I score myself 69%. Rounded to the nearest whole number, that's 7 out of 10. Okay. Likewise for loops. Next part of the rubric was to include loops. So if you had multiple loops used, at least 2 of for and while out of the for, while and do options. I know we only covered 2, so that's why I'm only looking for 2. If you have 2, both for and while, and you've got multiple occurrences of each of them, and nested loops, so that's a loop within a loop, then that would be excellent. So you'd score yourself an excellent mark. If you have multiple loops used but no nesting, then that's a very good mark. Get a good mark if you have an example of each type of loop. So for example, one for loop and one while loop, that's a good mark. A pass is a single loop statement included, line numbers shown. And a fail then is, I'm afraid of loops, I didn't include any. Okay, so I have for and while loops in my code at lines 23 and 37. I have a for inside a for at line 60. I'm recording an excellent mark for this, 100%. So I get 20 out of 20 for that. Then bespoke methods. Okay. Bespoke methods, writing your own methods that you can then call. So if you have multiple bespoke methods used, so you've both defined the method and you've used them with a method call, and you can show the line numbers where you did that, then that will be an excellent mark. Very good. 2 bespoke methods used, line numbers shown. Good is just 1. A pass is 1 method included but not called. So it's very easy to get marks there. And then a fail is, I'm afraid of using those, so I didn't include them. Okay. I have 3 bespoke methods at lines 46, 57 and 68, for example. They're called at these lines. I'm recording an excellent mark for this, 100%, and I get 20 out of 20. Next part is processing methods. So these are methods that you have not written yourself, but you're actually calling from the processing library. And I'm going to take a look at giving you some help at finding some ones that maybe we didn't cover in class, but to help you find other methods to make your programming even more interesting. So excellent would be you have more than 3 methods used. Line numbers are shown. Now, I think you'll find that it's very easy to get over 3. Okay. Very good is you just use 3. Good is 2. Pass, if you just use 1 method, we'll give you a pass. And a fail is not included or not working. I think it's very hard to submit an assignment and not include a method. Okay, it's going to be very difficult. I think it's impossible. I've used 2 processing methods, example 1 and example 2, at lines 54 and 33. So you'd replace example 1 and example 2 there with the actual methods that you were calling. I'm recording a good mark for this, 55%. And rounded to the nearest whole number, that would be 11 out of 20. When you check your rubric, you'll notice that it always says X out of a number. So what I'm doing is I'm getting the grade and then I'm converting that into an actual mark to give yourself a mark. Next thing is you have to do is you're asked for strings. We covered strings in the last class and also in that bonus video. So if you have used 3 string methods with the line number, more than 3 string methods, will give you an excellent mark. If you use 3 string methods, we'll give you very good. If you use 2, we give you good. Pass is where you use 1. And if you don't use any at all, we record a fail for that part. Okay. So as an example, I've used 2 string methods. Example 1 and 2 at lines 84 and 85. I'm recording a good mark for this. Rounded to the nearest whole number, that's 11 out of 20. Overall, if we calculate all of the marks that we got, I got 3 for part A, 10 for part B, 7 for part C, 20 for D, 20 for E, for F, and 11 for G. If I add up all of those, overall, I come in with a mark of 71. Okay. So I haven't yet asked you to then think about the complexity of your program. I think we'll do that for you, but you'll see that there's a multiplier. So you got 71 just for ticking all the boxes, and the next thing then is how difficult was the problem you were trying to solve. So if it was a really simple problem, you're going to get a pass mark or a good mark. If it's a really difficult problem, then that's going to go closer to 100%. So we multiply those 2 numbers and that will give you your overall grade. There's one other part, and that is potentially you may have to do an interview. We reserve the right to do the interviews to maintain the integrity of the assignments and of the course. So if you have to do an interview, you'll get a mark for the interview, and that's a multiplier as well. So if everything checks out, it's very easy to get 100% in it. If everything doesn't check out, it's very easy to get a 0% in it. And 0 multiplied by your overall mark would be 0. So we encourage you not to plagiarize. And that you have to be able to stand over all of the code that you write yourself. Okay, so I hope that helps out with the assignment. There was one thing I mentioned I would take a look at, and that was processing methods. So let's take a quick scan at that as well. So let me just swap over. So here's the link to the processing documentation site. Let me just bring this up. Okay, so you'll see it's processing.org/reference. Okay, and in there you can see all of the methods, and they're grouped into categories, and we've actually used quite a few of these already. So, for example, we've been using colors, and we've already used the background method. We've used the fill method, no fill. we've used no stroke, and we've used stroke. So we've actually used quite a few of these already. And you can see how easy it was to use them at the time. So there's no reason why you can't explore this reference to find other examples. If we take a look at some more that we've looked at, if we look at 2D primitives, you can see that we've already covered the square. We covered rectangle, and we covered line, and we covered ellipse. And you'll now see that there's circle, there's arc, point, quad for quadrilateral, we have a triangle and a square. So you can see it's very easy to include lots of method calls inside your assignment. So there's no reason why you can't get an excellent mark for calling methods. It actually, the spec sounds worse than it is to actually implement. Okay, so there's 2D primitives. So let's take a look at some more in here. That might be useful. Let's take a look at these ones. So we've talked about inputting, and we covered mouse events. So we looked at mouse button clicked, dragged, moved, pressed, released, and also the value of the mouse properties. So mouse X and mouse Y gives you the current XY values, but there's also the previous XY values, and we used that in one of our challenges. And I know I didn't ask everybody to worry about the challenges, but some of you did, and mouse X and mouse Y came up in one of those challenges. So I'd encourage you to maybe take a look at those. Okay. Take a look at some more. While we were looking at inputting, we also have keyboard input. So as part of input, we looked at mouse, but there's also keyboard. So if you want to take in values from the keyboard, you can actually use the keyboard to take in input. Don't worry about it. I'm just making you aware of some things that you might consider. You don't have to use any or all of these. Okay. We also used typography. So if we take a look at this, typography, we've already used the text method, but you can also change the text font. And we also saw the attributes of the text. So you change the width and the size, the alignment. We didn't look at alignment or leading or mode, but maybe they are ones that you can explore yourself. Okay. And there's lots more in there. I mentioned a couple of other ones. Strings. Let's take a look at strings. So we'll find string functions here. So we use the string class from Java, which is a bit more functional than what's here, but there's a join in there. There's also trim that we looked at, splitting a string up. And then there's the methods of the string class in Java. So I'm going to mention two others that might come in useful. One is random. Again, came up in a previous challenge. So if you take a look at the random function or random method, and also an operator that comes in useful and has popped up in one or two of the challenges, is the modulus operator. Okay, modulus operator. Let's see if I can find that in here. No, I'll come back to it. Okay, so that's a good little talk about your assignment. I hope at this stage we've allayed any fears. There is absolutely no reason whatsoever why you should be worried about this assignment. If the assignment is primarily based around what we did in weeks 1, weeks 2, and weeks 3, and the first part of the talk in week 4, which you could ignore. You know, you can just do the first 3. I'm not asking you to do object-oriented programs. We're asking you to do functions or methods. You may use some objects, but you certainly won't be expected to create your own, not at this stage. Okay? Okay, so I'm going to, I've been talking quite a bit there, and I haven't asked you to do anything. I'm going to take a little pause before I move on with the notes, and I'm going to ask if you have any questions around the assignment. Can you post those please now in Slack, and I'll try address those before we move on. Okay. And we'll just give a couple of minutes for that. I'll put up a holding screen in the meantime. Okay, thanks for your questions there. Just reviewing them. If we take a look, we had a question. Is it okay to use methods that we haven't covered in class? Yes, it is. So I've just been showing you some methods that we haven't covered in class. You can go and explore those yourselves, because you may want to achieve something in the project you're working on. And just because we haven't covered it doesn't mean that you can't do that if you can find a solution. What I would guard against, though, is going off and finding a solution to a problem, a full coding solution, and think that you can pass that off as your own. That would be quite difficult. We would absolutely encourage you to explore that reference to find new methods if you're comfortable with what you're doing. Okay, there's no reason that you have to, because you can simplify the problem to just what you know. But if you want to explore and expand, we have to encourage that. So by all means, you can do that. Will we need to explain them fully in comments and reflection? Not particularly, no. You don't have to explain it. Certainly in the comments, right? You might say why you're using this method, right? So that would make sense. In the reflection, I'm not going to be asking you to detail everything, but if we've just gone through the reflection and how you have to answer it. You have to say, I've used these methods, these lines of code, right? That's giving the evidence for calling methods. Your comments is where you would maybe explain what it's doing, but it's only a brief comment. Okay, so it shouldn't overload you too much. And another question, should the inline comments include explanation of each line of code, and the README is just a summary of each method, etc.? I would say it's good practice to have a comment on each method. Okay, I would always start a method with a comment, either just before it or just inside it. We can show you how to do that. You can use multi-line or you can use inline comments for doing that. Okay, I think that's all the questions in relation to the assignment. So I'm going to park the assignment now. And we're not going to talk about the assignment anymore during these talks. I've given a whole half hour over to it. So from here on in, any discussion on the assignment, let's see it up on Slack. And if it requires a video, we'll do a bonus video. Okay. Okay. Right. Let me get sorted here then, and I'll bring up our materials. Okay, let's see where we're at. No, wrong file. Okay, so I'm going to start where we finished the last day, which was in here. So in the last slide deck that we looked at, we were looking at classes and objects. We said that a class has properties or fields. Another name is variables or attributes. All these words mean the same thing. Okay, properties, fields, variables, attributes. We refer to these things inside of a class. We also have methods. Up to now, we've been using functions. Methods are functions. Okay, we refer to a function as a method when it's inside a class. So it's all about creating classes today. And in order to use properties and methods, we had to use this thing called the dot notation, okay, or the dot operator. So we got as far as the first 3 points. And what we're going to do is move on, creating our first class, and that will actually end up recapping on all of these first 3 points in doing so. So I'm going to jump to point 4. Okay. And then we'll continue then from there. Okay. So creating your first class called Spot. So this is what we're trying to do. We're going to start with a sample code that draws a white spot on a black background. And we will refactor this code by writing a class that will draw and format this spot. So refactoring, there's a new word. What we mean by refactoring is when we are taking code that already works, but we're putting it into a different structure and organizing it better so we can reuse it better in the future. Okay, so we've been writing programs. If you remember when we first started, we started writing lines of code just in an empty file, and it did something. And then we refactored that into a setup so that it ran once. And then we refactored it again into a draw method so that it would constantly be updated. We're doing something similar now when we move to using classes. We're using object-oriented programming. We're taking code that works. We're going to be putting it inside of a class. So here's some sample code. We have 3 variables. We have a setup and we have a draw, and this will draw a spot on the screen. And you've already done this in earlier weeks, so I'm not going to spend any time on explaining it. A class creates a unique data type. When creating a class, think carefully about what you want the code to do. You have to think about what are the attributes and what are the behaviors. So there's 2 keywords to write down: attributes and behaviors. First, we start by listing the attributes and figure out what the data type that they have should be. So what fields do we need to model the spot? Note, fields are the attributes or properties of the object we are modeling. Okay, so let's go to Slack and get you to answer that. So I'm just going to put fields of spot. And I'd like you to reply, please, in Slack. What information, what properties of the spot do you think we would need to record? Now you can see 3 on screen already. What other ones? Okay, so not just the 3 that you see on screen. What else might you want to record to describe the spot? Okay, you're getting the hang of it. That's great. So we have an x coordinate, a y coordinate. We also have a diameter. So they're the obvious ones. And then just to make you think a little bit more, yes, you could start thinking about the color. So does this spot have a color or not? Okay, and you already know about colors. You might have a fill color and you might have an outline color or a stroke color. So these are all things that you could consider specifying as being properties of the spot. Okay, very good. So when we talk about fields or properties or attributes, that's what we're talking about. How do you describe the object that you're trying to model in the class? Thanks very much for all your answers there. They're all fine. So let's move on a little bit more. The required fields or attributes are, in this example, we had x, y, and diameter, and all your other additional answers are perfectly valid as well, the colors. Okay, thanks for that. So the name of the class should be carefully considered and should match its purpose. So this is to do with naming. The name can be any word or words. It should begin with a capital letter. Now this is the big gotcha. Can you all please make a note of that? When we create a class, the first letter is capitalized. Okay, and this goes against what you've been learning about camel case. Okay, with camel case variables and methods, the first letter was always lowercase. But when we create classes, we don't use camel case. Okay, we have the first letter capitalized. If you're creating an object, it should not be pluralized. So you wouldn't say spots, you'd say spot. So for our class, we could use names like spot, dot, or circle. Okay, and we're going to use spot. So let's take a look at our class. Version 1. What we've done is in the orange box, you can see we've created a new class or a new object. Class is the keyword, and then next to it we have the name of the class, which is spot with a capital S. And what we've done is we've recorded inside of curly brackets the fields or properties associated with that object. So we have an x coordinate, we have a y coordinate, and we have a diameter. Now we have to specify what data type they are, and we've used float in this case. Okay, so this is our class. Again, defining the class, we have a capital S and we have a naming word that names the object and is not pluralized. These are the fields in the class, and to create one, you have to create the class not in the same file as all the rest of your code, but in a separate tab. So we haven't done that before, so let's take a look at how we might do that. If we switch to here, so let's say I've got a setup method and I want to create a class. I would click on this down arrow, new tab, and then what's the name for this file, and you give the exact same name as the class that you're going to create. So we want to create spot, so it's capital S, small p o t, and click OK. And what that's done is it's created a tab for spot, and now I can create my class spot like so, and we can start filling it in. Okay, so that's how you enter your code on a new tab. It's this drop down, new tab, and then case sensitive, spell the name of the class that you want to create. Okay, so can you all try that, please? Open up processing and just make sure you're comfortable with that. And if there's any hassle, just post a question on Slack if you're in trouble. Good question, Jessica. Should you actually have the brackets after the class spot? You're going to see we're going to be including them as we move on. So yeah, strictly speaking, yes. Or am I after? No. Sorry. Let's take them out. Sorry. Good catch. You don't have the brackets yet. We're going to be including the brackets when we create something called constructors in a moment. Sorry, I got ahead of myself. Thanks for that. Okay. Another question. What are the differences in creating a class lowercase spot instead of creating and calling a method spot with the same setup? Okay, great question. We're not creating methods. Okay, so a method is where you put a name on some lines of code that you want to be run. A class is something completely different. A class has methods inside it, but it also has properties, and the properties, in order to change them, you call methods to change them. So again, a class is a collection of both properties and methods, whereas a method is just a method. Okay. So again, I'm just going to read your question again. What are the differences in creating a class spot instead of creating and calling a method spot with the same setup? Because we're going to see as we develop and we look at more and more complications, you can do more and more things with your object. And the idea of the object is anything you can do with the object, you create a method to work on that object and you store it inside that class. So it'll become apparent as we do more examples. Okay. Okay, thanks for that. Let's move on. I have a star on that slide because when you're creating your classes, you need to do them on a separate tab each time. Okay. Okay, so here we have a variable SP. Okay. And this variable SP is just a variable, but it's got a data type, and the data type now is spot. Okay, so by creating the class spot, we can now create variables of that type. So once we have the variable, we can then create a new object of type spot. Okay, I think I'm just being distracted by one of you are having trouble with video. I think it's your own video connection. Everybody else seems to be fine. Yeah, so it's just yours, Jessica. Okay, I'll continue. Calling the spot constructor to build the SP object in memory. So what we've got is we declared a variable up here, SP of type spot. And here we're using the variable by initializing it, creating a new spot. So we have this new keyword and it's a new object. What type of object is it? It's an object of type spot, and spot is defined in the class up here. Okay. So initializing the fields in the SP object with a starting value. So now we can get at the fields of our object and give them values that we want. So here we have sp.x coordinate is 33, sp.y coordinate is 50, sp.diameter is 30. So what we're doing is we're putting values into each of these fields. And then finally, calling the ellipse method using the fields in the SP object as arguments. So here I've got a method draw, and I'm going to create an ellipse. And what values do I want to use? I want to use the values that are stored in my fields. So my fields are x coordinate, y coordinate, diameter. And I can get at those values because they're part of the spot object. I can get at them using this dot notation. So we have the name of the object, which is SP, dot, and then the field name. And the field name in this case is X coordinate, Y coordinate, and diameter. Okay, so let's look at constructors. Again, I would encourage you to just write that word down, constructors. A constructor is a method that gets called when you create a class. Okay, so let's take a look. If we have a variable SP, which is of type spot class, if you don't do anything, SP has a value of null. And we talked about this when we were looking at references versus values in an earlier class. So this declares an SP object variable initialized to null by default. So then we have what happens when we initialize it. So we initialize it by calling a constructor. So the keyword new calls the constructor. Let's highlight that. So we have the keyword new here, and new calls the constructor to allocate the object in memory and initialize its fields. So because they're float values, they get whatever the default value for a float is, and a float is a decimal number, so it's 0.0. So the values that are being stored for X coordinate, Y coordinate, and diameter, because they're all floats, is 0.0 in each one. And this happens because we said SP equals new spot. The new calls a constructor, and we haven't written that constructor yet, so it calls a default one. There's different types of constructors, and we're going to visit each one. So the SP object is constructed with the keyword new. Spot is the default constructor that's called to build the SP object in memory. So a constructor is a method that has the same name as the class but has no return type. Okay, so this is the method that gets called. So again, a constructor is a method that has the same name as the class but has no return type. So this is called the default constructor, and it has an empty parameter list. Hence my confusion a few minutes ago when we were typing in the class in processing. If you don't include a constructor in your class, the compiler inserts a default one for you in the background, i.e. you won't see it in your code. Here, the spot default constructor simply constructs the object and puts 0 values in for all your floats. So we now know that constructors store initial values in the fields of the object. They often receive external parameter values for this. In this code, we initialized X coordinate, Y coordinate, and diameter after calling the spot constructor. But you could actually pass those values in, and if you did, you'd be creating a constructor with parameters. So let's take a look at that. We want to write a new constructor that will take the 3 parameters X, pos, Y pos, and diameter. These values will be used to initialize the fields. So this is the constructor. So we are declaring spot brackets. Inside the brackets, what parameters are we taking in? We're taking in 3 floats, and we've given them names X pos, Y pos, and diameter. And when we take in those values, we can use those values then to store in the fields, which you see up here, using 3 assignment statements. So these are the parameters, these are the fields, and what we're doing is initializing the fields to what the values of the parameters are. So how might you make use of that type of constructor? Well, instead of saying SP equals new spot brackets brackets, you'd say SP equals new spot, and then you pass in the parameters. So the new bit is the 33, 50, and 30 that I've specified inside brackets, and those values get passed over into the constructor. So let's talk about overloading constructors. We can have as many constructors as our design requires once they have unique parameter lists. And we talked about overloading in an earlier class, and we said the unique parameter lists, they must be unique by type, not by name. We're overloading our constructors in version 3. So let's take a look at version 3. So here's a default constructor which has no parameters. And here's a second constructor that we just wrote. This one allows you to take in values for the x, y, and diameter. And that's it. Okay, so I'm going to pause there for a moment, and we'll then continue on. I think we'll just take a 5-minute breather. If you have any questions, you can post those onto Slack, and then we'll move on. Okay, let's get a timer up on screen. Okay, so we'll switch off for 5 minutes, okay? Okay, everybody, welcome back. So we're really at the start of today's class after an hour in. But you'll see on the slides that actually the first part of today's class is a recap on everything we've just covered before our little break there. So I'm going to maybe fly through some of that just again, just so you hear it a second time. But I'm not going to hang around on this because we've literally just covered it, okay? So, classes and objects. So we're talking about classes. Class defines a group of related fields and methods. And we had a question about why don't you just use a method? And the reason is because a method does one task, but a class can have many tasks that work on fields. A class is usually trying to represent some real-world object. You use fields to store values, and methods then work on those values, changing them. Okay, so an object is a single instance of a class. So we can have many copies, if you like, of a class. If you like, the class is the template. We talked about blueprints before. You can have a blueprint plan for a house. So the blueprint is the class, and the object then is the instance of that class. So when you build a house, that's an object or an instance of those plans. You can create many houses from the same set of plans. So that's the distinction between an object and a class. Many objects can be constructed from a single class definition. The analogy, another analogy was cake. A class is like a recipe for a cake. An object is the cake baked from the recipe, and you can bake lots of cakes from the same recipe. Okay, so lots of cakes being objects and the recipe being the class. Class names should match its purpose. Any words, we use a capital letter at the start, and it shouldn't be pluralized. And then we went through some examples the last day on apples. So again, for example, if we had two brands of apple, we have a class for apple, but then we can create two objects. Object one is the Gala object, which are red apples, and they have a certain weight. And then Golden Delicious, which are yellow apples, and they have a heavier weight. So these are instances of the apple class. Okay. We also saw using an object's fields and methods. The fields and methods of an object are accessed with the dot operator. So we're talking about dot notation. We have object.property or object.method. So for example, we could say Gala.color to get at the color field in the Gala object variable, which is of type apple class. And we also have Golden Delicious.color, which gets at the color field of the Golden Delicious object variable of the apple class. Likewise, we can use the dot operator to get at the method. So here we have Gala.grow, so grow being a method, and .fall is a method, Golden Delicious.fall. So using the dot operator or dot notation is what we're seeing there. Okay, so let's then just recap on what we've been talking about before the break. Constructors. We have three types of constructors, or three things to consider. The default constructor, which we actually don't have to specify, it's done anyway. We have a constructor with parameters, where we can create our own constructor, have fields or parameters, and then pass in the parameters to have them initialized to those values. And then we talked about overloading constructors, where we can have multiple constructor names. They all have the same name, but what's different is the parameter list. Okay, so that's really what's going on there. So we'll fly through it again. Here's the spot class. Declares the fields in the class. We have X, Y, and diameter. We showed you how to create it on a tab. And then we walk through creating a variable SP of type class, type spot class, type class spot. And then we initialized it by creating a new. The new calls the constructor and initializes the object variable. It will call the constructor. And this was the old way of doing it, where we're accessing the fields using the dot notation. SP is the object variable, the dot, and then which field do we want access to give it a value. And then here's where we're using those values again, accessing them through the dot operator in a call to an ellipse. So we said constructors are called when you use the new keyword. If you don't have a constructor defined, it will use the default constructor, which just initializes each one of the fields to their default values as defined by the language. And for floats, that's 0.0. So we said a constructor is a method that is the same name as the class but has no return type. Okay, so here it is getting initialized to 0.0 for each of the fields, and this is the default constructor. So if you don't write one, it actually implements this itself, the environment. But more often than not, we want to supply parameters to our objects so we can initialize them to some initial values that we want to specify. So what we're doing here is we're saying SP is the object variable. We're calling new, and then what type of object? It's a new spot object, and then this allows us to specify the initial values that we're passing in so that the object gets initialized to these values. And we're doing that here with spot, float xpos, float ypos, and float diameter. So basically we're passing the 33, 50, and 30 in as initial values when we're initializing the spot SP object variable. So overloading, okay, just to recap on overloading. Overloading is when you use the same name more than once. So we can have many constructors as our design requires. Once they have unique parameter lists, we're overloading our constructors in version 3. So here we have spot with no parameters, and here we have spot with 3 parameters. So spot has been overloaded. You have the same method name called spot used twice. What's different is the parameters inside the brackets. So when we do that, that's called overloading. So again, here's the class diagram for a spot. We have the object type or class name, we have the fields, and we have the methods. Okay, so that's a recap on the last day and also what we covered just before the break. We're now ready to move on. And what we're going to be doing now is we're going to add behaviors to the spot class. Another name for behavior is we're writing methods to work on the fields or the values in the fields of the class. So we're going to write 4 methods. We're going to write display. So we're going to use a method to draw a spot using the values that are in that spot object on the screen. We're also going to use color, so we can change the color of the spot. We're going to use move, so that we can move the spot around the screen. And then we're going to talk about something called name overloading. We've just spoken about method overloading. We're going to take a look at name overloading at the end to make our code easier to write. Okay, so that's what we're going to be looking at. So again, our spot has an object type or class name. We've got the fields and we've got the methods. So far, we've only overloaded constructors for our class. They create objects of our class. They create the objects of our class. We've not defined any behaviors for our class, for example, display, color, or move. As it stands, the spot class is not very useful because it doesn't do anything. How do we operate this spot? So that's what we're going to be working on. So the first thing is we want to do is we want to display it. We want to add a behavior to the spot class that will draw the spot on the screen. And to add behavior to a class, we write a method inside the class. We call this method display. So the method's signature is void display, open bracket, close bracket. The method's job is to draw the spot on the display window using the values stored in the attributes x coordinate, y coordinate, and diameter. Remember, we've used attributes. Another name for that is field or property. So here it is. We've got void display, and then to draw a method on screen, to draw a circle on screen, we were using ellipse, and we're using x coordinate, y coordinate, and diameter. I think I've included diameter twice there by mistake. Apologies. And again here. Oh no, I know what that is. Yeah. So we're using the diameter twice because we're calling the ellipse method. And when we use the ellipse method, you might remember that, let's pull that up. The ellipse method is built into processing. It takes an x, a y, it takes a width, and it takes a height. Okay, again, covered in week 1. So we don't need to specify width and height. That doesn't make sense in what we're doing in describing a spot. We just use diameter twice. Okay, and that's going to draw the spot on the screen. So to invoke it then, we have sp.display. So sp was our object variable. We're using the dot notation. So we want to call the display method of the sp object. And what that will do is call this method inside the class. And inside it, what does it do? It invokes an ellipse. Okay, and it makes use of the properties of the object variable which were stored up here. So this is our first method in our spot class. So our spot class diagram now looks like this. You can see with a class diagram, what we've got is 3 sections. The name of the class is on top, the name of the field's in the middle, and at the bottom we're seeing all the methods. And we're going to be growing this class diagram as we add more and more methods. So we've just added the display method. Now let's take a look at the color method. So we now want to add a behavior to the spot class that will color the spot using RGB values on the screen. We need 3 extra attributes. These are going to be fields, red, green and blue, and we're going to use integers. So we need to take in values for red, green and blue fields using the parameters of our new method. So we have color that will take in a red value, it takes in a green value, and it takes in a blue value, and they're integers as well. So here we see the new fields that we've added to our class. Then we're invoking the method color, passing in the parameters, which we'll call this new color method that we've just written. So again, just to go back over that, we want to use color, so we have to add 3 more fields. And when I asked the question in Slack earlier in the class, can you think of what properties a spot might have? Quite a few of you mentioned color. So this is how you would implement color. You would store values for the red, green and blue. And if we want to color our spot, then we use the color method invoked using the dot operator on our object variable sp, and this will end up calling this method inside your class, passing in the 2, 5, 5, 10 and 20 into red val, green val and blue val, and then we have assignment statements inside. So you can see that the red is assigned the value red val. What that means is the red field gets the value that you passed in, the green equals green val, the green property or green field gets the value that you passed in, and likewise for the blue. And then there's one extra line of code here, and that's the fill. So you can see fill red, green, blue. So what's happening here? It's going to change the fill color for the spot to be the values that you passed in. So that's how we're able to change the color of the spot. So then when you display in the next line the spot on screen, it's going to use the latest fill. So that's how you change the color of your object. So we now want to add a behavior to the spot class that colors the spot using the grayscale value on the screen. We learned in earlier classes that we can have both RGB values or grayscale. With grayscale, you only have to pass in 1 number. Okay, so let's take a look at how we'll implement that now. To add this behavior, we'll need 1 extra attribute or field or variable, Here we're calling it gray, G-R-A-Y, and we can call then color method using just that one value. So very similar to the last one. We're creating a new field called gray. We're still calling SP color, but this time we're only passing in one parameter. And then we're setting the gray field to that gray value and then changing the fill using just the one value gray. Okay. So what we've actually done now is we've written two color methods, or two methods with the same name color. One takes in one parameter, which we can see here. And we already previously had a method called color which took in 3 parameters. So when I use the same name for multiple methods, what am I actually doing? What's the term that we refer to for that? So I'm going to get you to answer this, please. So multiple methods with same name is referred to as what? If you could reply please in Slack. And we'll try keep them all in the thread, if you don't mind. Questions coming in as well. We'll take a look at those. Okay, so thanks for your answers, all correct, which is great. It's called overloading, so you are following along. Well done. Dermot, I'll take a look at your question at the end of class, if that's all right. I can't follow it just at the moment. I'll take a look at it at the end of class. Okay. So spot two color behaviors. So we've overloaded the color method. We have two methods called color that have different parameter lists, and you can see them on screen now. So that's the answer to the question that I just posed. Java knows which method to call based on matching the arguments passed to the method call, and we've seen overloading already, but here it is in practice again. Here we have an example call 1 sp.color, and it passes in 3 parameters, and here we have example call 2 in red sp.color, and it's just one value, 125. So inside our spot class, we have two methods. One takes in 3 parameters, one takes in 1 parameter, and I've color coded so that you can see how those calls get implemented. So the class diagram for Spot version 5 is now growing. So we have 2 constructors in our class, Spot with no values and Spot with 3 values. 2 new constructors are needed to initialize the Spot object to a starting gray color and RGB color. So what we're saying is we had a constructor which didn't do anything. Then we had a second constructor which took in 3 parameters. But now we want to also be able to specify the color. So in addition to our XPOS, YPOS and flow and diameter, we take in the gray color, and we can also take in the RGB values when we're initializing our Spot class. So we can now create a new SP variable by specifying 4 parameters, for example, the X and Y diameter and the gray color, which you see here. We can also do it with 6 parameters. So the X, the Y, the diameter, and then the R, G, and B. So we've grown our class diagram. It now has 4 overloaded Spot constructors. We had the first 2, and now we've just added 2 more. So next we're going to move on to move. So this determines where you're going to draw the spot or move the spot to. So let's take a look. We now want to add a behavior to the spot class that will move the spot around the screen. To add this behavior, we don't need any extra attributes, fields or variables, as we already store the coordinates of the spot. We will need to take in values for the new position of the spot. So where do you want to move it to? So you have to take in a new X and Y position. So we're going to call the move method, passing in those two new values. We'll declare a move method inside the class, and we will take in those parameters. And then we're using those parameters down here to update the X coordinate and Y coordinate field values to whatever values were passed in. So we're just updating the X and Y coordinates. And when we're doing that, we're actually moving the spot. So nothing too difficult there. Just updating the field values. So we now have a new method called move, which takes in two floats. And that's it. Okay. So last little thing is a little change, and this is just about tidying up your code and making your code easier to read and write and even automate. We'll see later in the semester when we move into using a new editor that mastering the this keyword, knowing how it works, is quite useful because it's going to enable us to have our program write our programs for us. Okay, so to get ready for that, we need to understand what the this keyword is about. Okay, so let's take a look. The class spot contains many fields: the X coordinate, Y coordinate, and diameter. One of the spot constructors takes three parameters: XPOS, YPOS, and diameter. It would be nice to name the parameters passed into the spot constructor the same names as the instance fields. This is called name overloading. So what we're saying is, if we could use the, if you look on the right hand side, we've got XPOS, YPOS, and DIAMTR. And if we look over here in the fields, we have X coord, Y coord, and diameter. And what we're trying to suggest is, wouldn't it be better if when we're writing our methods, if we actually could use the same names as the values we're going to change them to? So that you'd have, for example, X coord equals X coord, Y coord equals Y coord, and diameter equals diameter. So it's not quite that simple. There's one extra step that you need to make, and that extra step is that we need to use the this keyword, so that Java knows which you're referring to. Are you referring to the field, or are you referring to the parameter? And this is how we implement it. So what you'll notice here is we can use the this keyword to distinguish between them. Here we've got this.x coord equals x coord, this.y coord equals y coord, this.diameter equals diameter. Notice also that the parameters have the same names, x coord, y coord, and diameter, as the fields that you've already declared. So this is just one extra little step where we're trying to use the parameters that we pass in. We want those to be the exact same names as the fields that we're using in our class, and to distinguish between the fields and the parameters, we need to use the this keyword. Okay, and this is called name overloading. So again, this refers to the current object fields. These are the local fields that are destroyed as soon as the spot constructor finishes executing. Here's another example. We used RGB a moment ago. Let's take a look at it for color when we're using the gray. So we can see down here, this dot gray equals gray, and then fill this dot gray. So we're taking in the color that you want to fill it, and instead of using a different parameter name here, we're using the exact same name as we use in our field, and then we're able to use this dot, the field name, equals the parameter name. Okay, might just write that up actually. let me just try something here for 1 second. Yeah, let's write that in. So what I'm saying is you can say this dot field name is assigned a value parameter name. Let's just shorten that. So I would advise you maybe to just write that down. This dot field name equals param name, and that's how we use the this keyword in our code. Okay. Okay. So to clarify, in the statement, this.x is assigned a value x, where this.x refers to the object's property or field, and x on its own is the parameter passed into the field name. Substitute x for any property or field. Okay, again, let's do this. Sorry, just lost my mouse pointer. There we go. Okay. Sorry about that. I lost my mouse pointer. I'll just restart again. So what I was trying to do was, let's do it the old way. And let's turn on our pen. Yeah. Okay, so what we're saying is this.x refers to the field, okay, and x on its own is the parameter. Okay, cool. And what we're describing here is name overloading. Okay, so that completes that slide deck. Okay, so I do have another set of slides to get through, but I've decided I'm not going to cover those today. I'm not even going to start into them because I don't like starting and not finishing. Let's pause there. I think we've covered more than enough, and we'll just pick up next week. I'll reorganize the notes and slides for next week. That's more than enough. Just like to point out at this stage that what we've been covering this week is object-oriented programming. So we're taking our time with this, the dot notation, the notion of objects, classes, methods, overloading, and the next topic is I'm looking down just to make sure, encapsulation, which is another object-oriented topic. You don't actually need any of these topics to complete your first assignment, so steady as it goes. Okay, so we've got a couple of minutes left. I'm quite happy to take any questions. I'm going to pose one for you, so if you wouldn't mind going to Socrative. Let's get that sorted. So I'm going to pose a quiz for you in Socrative. Let's get you working on this. Two questions. So for those of you that are joining us for the first time today, you need to go to Socrative.com, log in as a student. There's a student login button. It'll ask you for your name, and the room name that it'll ask you for is C. Dunphy, C-D-U-N-P-H-Y. And I'm posing a question there at the moment. And the question is, we're going to create a computer or class object. What properties should be part of this class? So I want you to think about, you're buying a computer. You don't just go in and buy the one with all the flashing lights and the go faster stripes. There are properties of a computer that you consider. So if you're going to model a computer, in a Java program or a processing program, there are properties that you might want to include in that class. So what properties of a computer do you think you might store? Maybe just to get you started, I'll give you an example of a property. It might be the brand. So is it a Dell? Is it an Apple? Is it a Acer? These are all things that you might consider when buying a computer. So therefore they are properties of a computer, the brand name. Another one might be the processor. What else would you consider? So come up with a list, and if you wouldn't mind just replying to that. Let's just to get you answering a bit quicker, give me 5 properties. Okay, maximum of 5 properties. Okay, we might just take a look at your answers. Great. So brand, model, RAM, storage, processor, memory, processor, GPU, HDD, motherboard, operating system, screen size. Yeah, you get the idea. So these are all properties of a computer. So the next thing you might consider then is what data type would you need in order to store each one of those things. So would it be a number? If so, it might be an integer. Is it a decimal number? If so, it's a float. Or is it a name? So therefore you might need to store it as a string. So you need a string object. Okay, so we're just trying to get you thinking about how you might store these things in a computer program. I've got one more question for you, similar and a follow-up. So let's take a look at the next one. We're going to create a computer class object, just as before. What methods should be part of this class? Remember, the methods work on the fields, or they work on the properties. So this one's a little bit harder. And you may not have considered all the fields that you need in order to be able to implement all the methods. So when you start thinking of methods, you might discover that, oh, I need a field to store such and such value. So again, I'm going to make this one a bit simpler. I would like everybody to try give me a maximum of 2 methods, just 2. Just give me their method names. You don't have to explain how they're implemented, just things that you might like to do with a computer. And I'm going to leave the answers available so you can get ideas from other people's answers and see, can you give me different ones? What I like about the first answer there was the fact that you're using brackets after your method names. So you're calling a method. Yeah, great. I've got somebody who's answered, I think, the previous question in this one. So the RAM size and screen size, yeah, they're part of the previous question. They're properties. Remember that methods have to be action words. Okay, they're verbs. So display, print, start operating system, boot, as in boot up, shut down. Yeah. Speed and weight, no, these are properties, but maybe there used to be buttons on old computers that you could press that had the turbo button, so you could make your computer operate at a faster speed. So you could say turn turbo on. Okay. So guys, thanks very much. This is just to get you thinking about how to write in an object-oriented way. Best of luck with your assignment. Don't forget, you've got classes today. You've got an optional session today at 9 o'clock tonight. If you want, Jonathan will be online in Slack to answer your questions. And again at 8:30 on Friday night. Something we're trying out this week. We're going to give an hour dedicated to trying to respond in real time and see how it goes. So that's it for today. Again, if you've had any further questions, you can post those on Slack. But for now, I'm going to ask you please to take an exit ticket on today's materials. If you wouldn't mind taking the exit ticket before you go, please. The question 3 is there anything I covered in today's class specifically that you're worried about? Okay, we want to know about what you're worried about so we can give you some additional help if needed. So that's what question 3 is. Okay, folks, thanks very much, and we'll talk to you again next week. Okay, bye.